to go through. So let's kick this right off and make sure my thing works great. So just a bit about myself to give you a sense of where I'm coming from. I'm pretty clearly not Norwegian or from the UK. I'm from Austin, Texas. This dot down here, the home of University of Texas, if not the second largest university in the United States. Hook'em Horns, the Longhorns, home of Edsger Dijkstra before he died, and many other famous CS people. Very strong computer school, great place to be. This is a great city. If you've never been to Austin, it's a wonderful place to visit. They're really big on music there. They're really big on rock and roll and blues. And this is a statue that the city built of a famous guitarist, Stevie Ray Vaughan, kind of a patron saint of music in the town. So that gives you some sense of the flavor. That's the city there in the background. Wonderful place. About 5 years ago, I moved to Stavanger, Norway, up here on the west coast of Norway. This is a part of the country. The entire country is beautiful, but this is a particularly beautiful part of the country. This is a view from our famous local landmark, Preikestolen, the Pulpit Rock, looking down a beautiful fjord on a beautiful day. If you're ever in Norway, ever in Stavanger, you should go there. This is what the country looks like. It's an incredible place, if it's not raining, which 90% of the time, so yeah, it's a crapshoot. But if you're lucky, this is what you get. The statues in Norway, at least in Stavanger, run a little bit more military. These are the 20-foot tall stone swords thrust into the earth commemorating the battle that united the three kingdoms of Norway. This is down the street from where I live, and Hafrsfjord is off to the, I guess, to your left in that picture. Very pretty, but not a guitar player, so different flavor. That's me. Before I go on, I want to ask, does anybody in here use Gerrit? Or has used it? Has anybody used Jenkins? Okay, good. Gerrit is in my estimation, the more complicated of the two tools, the more sort of revolutionary in some sense of the two tools. And so this is good. I didn't want to be talking to a room full of people who already knew how to use these tools, because a lot of this talk is just about what they are, how to set them up, how to make get the most out of them. So if you're already using them, this would be a waste of time. So not a complete waste of time, but a waste of time. 60 North, that's my company. So let's just dig right into this. A typical automated testing scenario. This I wanted to kind of describe where a lot of companies are in my experience. You've got companies often start, especially like kind of existing companies with legacy code. They're successful, but they found themselves in a mess. And they started off in a situation where they have no tests. This is very typical. 15 years ago, 10 years ago, it wasn't as fashionable. Fashionable is the wrong word. It wasn't as well recognized that testing is an important part of software development. So you had a lot of companies in this situation. They wised up, they get a bit smarter, and they start adding unit tests. Maybe some developers drive this effort. They say, we're going to add unit tests because we recognize this is how we maintain quality. This is how we assure that regressions don't enter the code, et cetera, et cetera. And this is a good thing. So developers starting to run unit tests, they have some assurance. They get more sophisticated. The organization grows a development team, a testing team. They get acceptance tests and integration tests. And this is also good, but these tests are bigger and bigger. These tests are so big often that they can't be run by individual developers. So a developer has to submit their code before they've actually run their code through all the tests. So you start to have situations where developers have to rely on another team and can't be entirely sure that the change they've made is 100% good. And ultimately, a lot of these organizations, they end up with an automated test system. They have a way to, they don't need humans running all the tests. And this is a really good situation, much better than the no test situation. Unfortunately, this is where a lot of groups stop. They have the ability to run all these tests when code has been submitted. This is good. This is actually great compared to where they started, but there's still a big problem. In many organizations, if I make a commit and it's bad, and it has to go through some automated testing cycle, it's entirely possible, in fact very likely, somebody else is going to pick up that change before we find out that it's bad. And by the time my automated test system has raised the red flag and said, hey, there's a problem with this, I may have infected my entire development team, and people have to stop working, because they don't know at this point if they can continue working on top of the shaky grounds that they started on. And so you end up with a log jam. You end up with the entire organization, maybe 10 developers on a team, something like that, have to stop, because they can't really move forward until we get the things cleared up, and they have to sort out who caused the problem, what the problem is, fix it, and then submit it, and then they can continue work. I'm sure people have been in, or some of you have been in a situation like this, and it's tragic because it really it breaks everybody's flow unnecessarily. When you have more developers, you run into even more problems, of course. But this is a somewhat synthetic graph. But the idea is if I have I think this was based on 10% chance of submitting making a bad commit in a day. For every developer on my team, a 10% chance. As my number of developers grows, this graph tells me how likely it is that I'm going to have a bad commit in a day. If I get to 7 developers, that's a 50% chance. Once every 2 days, I break the build and everybody has to stop working. So if my number 10% is wrong, then of course this graph is worse, and if it's lower than that, it's a little bit better. But the point is, as your development team grows, you get this curve that tells you how often you're going to break. And this is something that you would like to avoid. And this is where Gerrit and Jenkins come in to help. This is a picture here of a quarantine ship. The point of a quarantine ship was to stop other ships before they got into the harbor, or as they came into the harbor, to tell them you have to wait here for, I think it was 4 weeks. That's where the word quarantine comes from stopping the Black Plague from entering Venice or something like that. Although this is clearly not Venice. Gerrit and Jenkins are the quarantine. Gerrit gives you a way to take a commit and have it run through the automated test cycle to become part of your repository without going onto the head of your development branch, so that it doesn't become public immediately. And this is what protects you from this curve. If I, as a developer, make a bad commit using Gerrit, and then Jenkins tells me, hey, you've done something really wrong, it doesn't affect anybody else. And this is a tremendous, tremendous win for a lot of teams. And so if I can get one idea into your head from this talk, it's that you want to get into this kind of situation where your bad commits don't infect other people and you stop this logjam situation that so many people find themselves in. So the rest of this talk is going to be about those tools, how to get to that state, and then how to properly leverage those and some kind of best practices and experiences and things like that. And some kind of fun stuff at the end, time permitting. There's quite a bit of material in here, so we may not get to the really fun stuff at the end, but you can always get these slides after the fact, I believe. Why testing and review? This is a good question. I'm going to take it largely for granted that you are in this talk because you think that testing and review are probably worthwhile, worth doing. That's what these tools are for, and I hope that you at least have some sense of what Gerrit and Jenkins are for. But just to give you a quick overview, there's a lot of reasons that testing and review are really good for you. Defect reduction, because of course you're detecting things early. You have reviews and you have tests that catch defects. That's easy. That's easy to understand. This results in significantly reduced costs for almost every organization because the sooner you catch defects, of course, the sooner you can fix them. If they don't make it out to your customer, you reduce the multiplier of the cost, and we'll look at a graph of that in a second. There are cultural benefits. This has mostly to do with reviews. If you have a strong culture of review in your team, then everybody feels enabled, everybody feels like they're really working on a team, and it's a great morale booster. So there's real reasons to do a lot of review. Your code quality improves. If you have a code standard, you ensure that people are following it. Your quality attributes, think your architectural drivers and stuff, are looked after much more easily if you have a strong review and testing regime set up. And of course, Gerrit and Jenkins can help you with that. I talked about cost reduction. This is something that some of you have probably seen. If you've read any sort of cost estimation, any sort of software estimation books, or software project management books, you've probably seen a graph similar to this. These numbers are cost multipliers. So if I detect a defect in the requirements phase, it costs me 1 unit, $100. I don't know what it is, it doesn't matter. If I find it in the design phase, pre-code 3 times, if I find it in the coding phase 5 times, 10, 20. These numbers are not, they're not scripture. You'll see these numbers float around in different studies will give you different numbers, but there are something along these lines. The point is that it gets significantly more expensive to fix defects as they get farther and farther towards the customer. 20 times is not too surprising, because if a customer finds a defect, they have to file a report, it has to go back through your system, you have to make a build, you have to fix it. Depending on your software setup and your infrastructure, this can be a real problem. So you would like to catch them as early as possible. Okay, so do good requirements. I can't help you with that. I can, but I'm not going to help you in this talk. It's very complicated. Do good design. This is where Gerrit and Jenkins are going to help you. They're going to help you find defects in the coding phase, in the pre-submit, pre-testing. And by testing here, I mean big, heavyweight integration testing, things that require dedicated teams and big machines, things that have made it past the development phase, which doesn't have meaning for some groups, but does have meaning for lots of groups, especially kind of legacy, old-school applications that still, unfortunately, dominate a lot of software. So this is a tremendous driver for a lot of organizations to do testing and review. And if you have to ever justify yourself to management, this is the kind of thing they're going to want to know about. Because it's easy to look at testing and review and say, oh, these just take more time. They don't really bias a whole lot. They just kind of make you feel good. But if you can show them this and show them the studies that this is derived from, you can convince the money people that testing and review is a really good thing to do because you save them that 20x. You give them 5 instead of 20. That's brilliant. So that's all I'm going to say on testing and review. I hope that everybody is kind of agrees with me that it's a good thing. If you don't agree with me, then I'm not really sure why you're here. Also, before I go any farther, if you have questions, I want you to hold them to the end if possible, unless they are questions that, if left unanswered, would leave you unable to understand the rest of the talk. If for some reason I've just left out an important detail for you, let me know. But if you just have some question that could be answered at the end, please save it for the end. So yeah, keep that in mind. So let's do a quick sort of 30,000-foot introduction to Gerrit and Jenkins. Gerrit is a number of things. Gerrit plays a number of roles in your development infrastructure. The first thing it is a code review tool. This is basic, its raison d'etre. This is why it exists. It is a way for you to submit some code, have other people look at it, have them vote on it, make comments, have automated tools look at it, Jenkins being one. So this is the role that most people kind of associate with Gerrit, especially at first. And really, this is the role that most people sort of interact with it with throughout their use of the tool. Most developers, this is their sense of what Gerrit is. Gerrit is also a Git server. Gerrit doesn't use an existing Git installation. Gerrit is a Git server. And this is something I'm going to kind of hammer on a little bit because it's true. And it gives you a much better sense of the kind of how Gerrit is architected, what its point is. So it literally does, the Gerrit process serves as your Git server. There's not some external Git server that it's proxying out to. So it's a much simpler architecture in some ways than if it was kind of shelling out to somebody else. Finally, Gerrit is a gatekeeper. It's the Black Knight from Monty Python, right? Gerrit is, in its role as doing quarantine, it is there to ensure that quality checks, that reviews, that code standards are checked before you make any sort of commit to the public branch, so that you can ensure that nobody's getting these bad commits and nobody's getting crappy code that you want to avoid. So it kind of stands there at the gate and or at the bridge, I suppose, and make sure that nobody gets across without chopping his arms off, I suppose, because that was how it happened in the movie. The basic Gerrit workflow is really pretty straightforward. The first thing, from a developer's point of view, you're going to update the head. You're going to ask Gerrit, please give me the development head, whatever that happens to be. You get that into your local repository. The next thing you're going to do is make your changes. You make them locally, and then you commit them locally into your local Git repository. Once you are satisfied locally with your changes, and maybe that involves running some tests, you're going to push that up to Gerrit. Gerrit invents a magical place for your commit to live so that other people can see it without that having to end up on some public repository. It gets reviewed, and potentially you have to go steps 2 through 4 several times until you get consensus, until you've made the changes that everybody agrees are correct and that all the flags are ticked and all that kind of stuff. Ultimately, hopefully you pass review, or you can abandon it, but assuming you pass review, you then merge that change into the head of your development branch. So it's a very, very intuitive, very simple, very straightforward model. The only real trick that it pulls, and it's a powerful one, is this step 3, where it invents this special place for changes to live before they get merged into the head. And in some sense, this is just leveraging the power of Git. Who uses Git on a regular basis, or is comfortable with it, or it just kind of knows how it works? Okay. Using Gerrit requires basically that you know how to use Git. You don't have to be an expert. I've worked with a lot of people using Gerrit who know 4 or 5 commands, something like that, enough to make this cycle run, but aren't doing things like interactive rebases and all sorts of fancy stuff. So you need to get a little bit comfortable with Git. And the beauty of it is, as you become more sophisticated with Git, as you learn more how to use it, all of that applies to what you're doing with Gerrit, and you can do really fancy, amazing things. And that's part of becoming hyper-productive with Gerrit and Jenkins. So this is the basic Gerrit workflow. This is from the Gerrit documentation. This is kind of a logical structure of how it's put together. You've got developers fetching from the authoritative repository, what I call the head of the development branch. Excuse me. When they push their changes, they go into this special place of pending changes. Reviewers, when they come in and want to review code, they look at code that sits here, and when it's approved, it's finally submitted up to here. Continuous integration build servers typically will read from there. Like if you have some kind of release every day kind of policy at your work, this guy's just going to read this once a day and he's going to make a new release. before we go any farther, a lot of people think that, say, well, Jenkins lives right here, right? And Jenkins can live right there and do this work, but Jenkins can also live down here and act as a reviewer, and that's the role that we're going to be talking about for Jenkins in this talk today. So you imagine Jenkins doing this job as well as sitting down here as a reviewer, just like a human, checking the boxes.
Just ask really quickly. You've got first approach how many changes. Are those logically separate little trees that can branch on the Git repository?
Yeah, you can think of this as a special set of branches. Yeah, that's the best way to think about it. They call them magical refs because they're sort of automatically generated for you, but yeah, they're just branches, really.
You've got two developers there both pushing things, so there's actually two separate.
Yeah, two separate developers.
No, it's two separate. It looks like, does it look like two separate branches in the Gerrit?
It does, yeah. So we'll get into the details, but basically when I do a push to the pending changes, I give it a unique ID, and then that gets associated with review, and we'll see all the details later. But yes, there's two separate places that their changes go, and then they ultimately get merged up if they're not bad. So that's Gerrit in a nutshell. Jenkins, in general, Jenkins is a task automation system. Jenkins, you can ask it to do pretty much anything. You can ask it to have it to run shell scripts, you can have it run executables, you can have it delete your hard drive, whatever you want it to do. So it really can just do just about anything. It's just a way to schedule jobs to get run when a certain set of events are received or when you push a button somewhere. For our purposes, primarily we're going to think of Jenkins as a build and test controller. So he's going to see commits into Gerrit. He's going to grab those commits and he's going to run. I say he, it's a piece of software, but his name is Jenkins, so I'm going to call him a he. He's going to build the software, he's going to run your tests, and he's going to say yes or no. The build worked and the test is passed, or something failed, and he's going to give you a red X, and you're not going to get to submit. So Jenkins is really pretty simple from our point of view. The way he works is he checks code out from source control, in this case Gerrit. He runs the build, he runs a bunch of tests, and then he says yes or no. That's all that Jenkins does. We'll spend actually significantly less time talking about Jenkins because it is so simple. And I just want to get you the key concepts of Jenkins in this talk. Most of this is going to be Gerrit and making sure that Gerrit and Jenkins are handshaking properly. This is a bit of repetition, but this is the flow. I, as a developer, commit to revision control. Gerrit sends out a message to Jenkins. Jenkins sees it, checks it out, says yes or no. So this is kind of how it works. All put together, all the pieces put together is step one, I push something to Gerrit. Step two, well, 2A at least, a human reviewer can come in and grab that and review it and make votes. 2B is Jenkins gets notification, checks it out, builds and tests, makes a vote, and perhaps I have to go around in circles a few times until everybody's satisfied, and once everybody's satisfied and has checked yes on the review, it gets merged in. This is it in some sense. This is the system that I want to talk about for another, roughly an hour. It's simple conceptually, and it's putting it together that's a little bit fiddly, and hopefully by the end of this talk you'll have enough motivation to try it out yourselves if you have permission to do so at work. There's a funny cartoon, or not a cartoon, I guess, a little movie I found that somebody said this describes Gerrit and Jenkins completely, and it kind of does, because you have this kind of cycle. You're just continually submitting, waiting for reviews, submitting, waiting for reviews. And I guess this is Jenkins off to the side just saying, yeah, everything looks good. They never shake their head no, so that's a bit unrealistic, but it's a cute picture, so I thought I'd put it up there for you guys. I'm not sure what it's from. It came from Reddit originally, or for me at least. So that was the 30,000-foot view. We're going to drop down a bit here and look at key Gerrit concepts, basically the terminology and the lower-level details that you need to have in your head when you start working with Gerrit to use it most effectively. I mentioned Gerrit is a Git server, and it serves as your master repository. This is the typical flow is that Gerrit literally is your master repository. So if somebody wants to find out what the head of your release branch is, they go to Gerrit and find out. You can, of course, have more complicated topologies. You can have Gerrit is the thing that all your developers and build machines and stuff are looking towards, and then you can occasionally clone that to some other repository somewhere, because Git lets you do that. I've worked on systems where Git is actually being cloned, the Gerrit repository is being cloned into Perforce. It's not pretty, but it works, especially if you have people pushing into that Perforce repository from another direction, and you have to do two-way merges and stuff like that. It can be done. It's kind of a hassle, but by and large, this is how most Gerrit-based development teams work. Gerrit is the answer. So when you clone from Git, you're just cloning from Gerrit. When you pull from Gerrit, these are the commands you're running against the Gerrit server itself. Gerrit is also an SSH server. This is great if you're having to write administrative scripts and stuff like that. There's a lot of stuff you can do over this SSH connection that may be tedious to do as a person. You can access almost all review activities. If you want to like download what's going on, what happened today, you can get a listing of that. You can do a lot of administrative tasks, add users, that kind of stuff. Like I said, it's great for automation. There is no interactive SSH, so you can't just like SSH into it and LS around and do stuff like that. But there's a lot of stuff you can do with SSH. So that's good to keep in mind. We're not going to go into the details of those commands, but it's good to know about because it's very useful for some things, especially if you end up having to write, for example, a two-way bridge between perforce that's receiving commits. This is the hook that you would use then to make a lot of that kind of stuff work. Gerrit is also an HTTP server. This is the interface that most developers will be interacting with most of the time. They will come here and be able to see a list of open reviews. So they may go to their personal page and see what reviews they have open, what things they're supposed to be doing for reviews, their recently closed items, and so forth. We'll see more of that later on, but this is where as a developer, I would spend maybe 90% of my time on this and on more specific, review-specific pages. And then the HTTP interface, the web interface, is where most people spend all their time. Very few developers will need to use the SSH interface. Of course, they use Git, but that, they don't generally think of that as a GUI or a user interface of any sort. Gerrit has a concept of users. And this is probably not too terribly surprising, but everybody who uses Gerrit is going to have a user account of some sort that manages access rights. You can control, for instance, who's allowed to actually do a merge, or who's allowed to do reviews, or who's allowed to configure Gerrit. So user access controls all of that. There's a lot of ways to do authentication. LDAP was very easy to set up when I used it. OpenID was extremely easy to set up. You can have custom mechanisms if you want. There is a sort of development mode if you want to use really easy setup for experimentation. We'll actually see that later when we set up Gerrit in a few minutes. Again, probably not surprising that it has users, but it does, so it's worth keeping in mind. Another important notion and concept in Gerrit is that of projects. A project corresponds directly to a Git repository. So if somebody tells you that they're working against some Gerrit project, that means that there's a Git repository managed by their Gerrit server that they've checked out and they are working against. A single Gerrit installation can host as many projects as you want, so it can have as many Git repositories kind of embedded in it as you want. So this picture just shows a bunch of barrels because barrels mean database and database means where you store stuff. I'm not sure how that ever got picked up, but it is the case. Again, probably not terribly surprising that Git has a notion of projects. Gerrit has a notion of projects. If you've named a project name, and this is probably not the easiest thing to read, and I'm sorry about that, but this is just showing you how you can clone from a Gerrit repository. If you know the name of the project, you say git clone URL of the Gerrit installation, and then the project name, and it's really that simple. We'll see that in action in just a little bit. Gerrit, of course, has project branches. Yeah, this is, I searched for the most horrible branching picture I could find. This is from GitK, I believe, so this is a real project somewhere. Gerrit has project branches because it has Git branches. That's all that Gerrit's project branches are Git branches. So everything you know about Git applies to this. You manage the branches exactly like you would manage Git branches, and you have all the power and all the flexibility to get confused as well as you do with standard Git. Bit of water here. So up to now, probably nothing I've told you about Gerrit has been all that terribly surprising. Users, branches, projects, that kind of stuff. The first kind of surprising thing is this concept of the magical refs. So the magical refs are refs in the Git server that are created for you for reviews and for drafts. I think there are a few other magical branches, or magical refs, but I've never used them for anything. Essentially what happens is when I push to this ref, and we'll see some examples of this, so don't worry if this doesn't make a whole lot of sense right now. If I push to this ref, so refs for branch name in some Gerrit repository, a special pending review branch thing is made for me by Gerrit, and that's the thing that people can clone from to do the review. We'll talk more about reviews later. Drafts are like reviews, except they're not generally intended to be reviewed. They're a place for you kind of to stash code, or if you want an easy way to share code with somebody else, like say I've made some experimental change and I want Bob down the hall to see it, I can create a draft, tell Bob about it, and Bob can clone that draft and see it, check it out, use it, make comments, make changes, whatever. There's no huge substantial difference between the two, but these are the two magic refs that your developers, or you as a developer, are likely to ever be using. Push for review, push for draft. And we'll see examples of how to use the review push in a little bit. As you might imagine, Gerrit has a concept of a review. A review generally corresponds to something like a new feature or a defect fix. It's essentially a developer's attempt to get some code that makes a specific change into the master repository. They want to get it through review, and so they push it up and create a new review. There's no magic to them, beyond the magic ref, which is what it's called, except one thing to always keep in mind is that Gerrit expects this thing called a change ID. A change ID is just a string that you include in your git commit for a review. And then Gerrit looks for that and uses it essentially as the unique ID for a particular review. So you can make multiple commits to a single review, even unrelated commits if you want. That's a bit of a headache, but you can do it. That as long as they all have the same change ID, Gerrit will think they all belong kind of in sequence. They're all iterations or evolutions of a change. We'll see exactly how to manage change IDs in the future, but the review is sort of the central concept to reviews. Part and parcel of reviews in Gerrit is this notion of a patch set, and this is just a single commit to a review, a single diff, and that's what I've shown here. This is actually a screen cap of the diffs that Gerrit can give you by default. People complain that those aren't the prettiest diffs in the world, and they're not, I suppose, but once you learn how to read them, they become like any other diff tool. They're just, you stop seeing the ugliness and just start seeing the diffs, which is fine. You will often have multiple patch sets for a single review, and that just means that often what that means is I've made a commit, somebody reviewed it, said they didn't like it, I've tried to fix it, make another commit, that gives me a new patch in that review, and they just kind of line up beneath one another in the review page, which we'll see in a bit. Most often when I'm making a second patch set for a commit, what I'm doing is cloning out the first patch set that I created, making some changes locally, and then amending the original commit. So for those of you who aren't real big into Git yet, amend just means update the last commit that I made, basically change the past a little bit. This is not, it sounds a little sneaky, but it's not. It's perfectly legitimate Git thing to do. So
that's after you pushed it to the server.
The amend?
Yes.
No, it's not. The amend is something that I would do at the developer's end of things on my local repository.
So no one else could have that history that you're now amending?
Yes and no. Gerrit basically takes care of that for you. Gerrit creates a second patch set. So yeah, you're right that often that's frowned upon to make amends to things that have been pushed to a central server, but in this case, it's legit. It's the recommended thing to do. And we'll see that flow in a little bit. And then, of course, Gerrit has this notion of voting. So the basic principle is that if you've got a review going on, you specify some people to do the reviews for you, and they all get a chance to make a vote. Typically, votes take the form of something like -2 to +2, where a -2 means absolutely do not commit this, you've done something horribly wrong, to +2 meaning I know exactly what you did, it looks good, and I approve, and you can commit. 0 means no comment. Plus or minus 1 can mean whatever you want it to mean. Really, this is up to you to set policy in your own organization to what this voting really means. And you might be able to go plus and minus 3. I'm not sure how configurable that is, but I've never seen anything except for -2 to +2. That's the default. Reviewers vote on specific patch sets, and this is I guess important. They don't vote on an overall review. They simply get to look at each patch set and say, okay, this looks good, or they can make comments and say, I don't like this, and this is what I need. This is what I need you to do to fix it. Not complicated, but central to the whole process. I mentioned Gerrit drafts earlier. They're like a review, but they don't necessarily get reviewed. They're just the same mechanism behind the scenes, but they're just a safety place for leaving stuff. You know, if like going on vacation and you've got a lot of work you want to save, and you're worried that your machine might go down for some reason, you can always make a draft and it'll be safe, or as safe as your Gerrit server is. It's a way to save work, a way to share work, a way to kind of just feel better about the safety of some changes you've got. It's a great place to put experiments too. I talk about experimentation in the title of this talk. And one of the things that Gerrit really frees you up to do is try crazy things, because you've got a nice, safe, quarantined place to put stuff that your automated test system can see and run all of your tests against. And you can get a lot of good feedback about wacky things. I really like this picture, hot work in progress. That's what drafts are for your hot work. I assume that's asphalt. work in China or something. Anyhow, drafts, useful to know about, not really central to most workflows, but handy when you need them. This next couple of slides I included purely so that if you download the slides, you can see the steps you go through to work with Gerrit. I'm not going to read these to you, but there's a couple of pages here of just 1, 2, 3, 4, 5 instructions on how to do specific things. We'll actually do some of these things live just to give you a sense of how it all works, but these slides should be available through the DevWeek people, and if they're not, I'll probably put them up on SlideShare or Speaker Deck or something like that. They'll be around, I think. Nothing in here is rocket science either. If you go out and you start reading about how to use Gerrit, you'll find very similar instructions, but I wanted to be complete. Yeah, you may have to do this as many times as necessary. This is the review cycle. So now we're going to actually do a demo of setting up Gerrit. This may seem a bit tedious, like, can't you just accept that it can be installed? What I want to show you, what I want to convince you of, is that this is really, really easy to do. You can do this in about 20 minutes, set it up at work, and get a small team, maybe experimenting with it. Get your group, your project, whatever, trying it out. There's a very, very low barrier of entry to trying out Gerrit. Jenkins is a bit higher, but Gerrit is really simple to try out if you want to get a feel for how it works and just try to get reviews integrated into your workflow. So I'm going to turn around so that I can see what I'm doing, and hopefully this will all work out. Drop out of this. Okay. Oh. Okay. Is that big enough font? If the stuff you'll need to see is going to be in white. Is that okay? No complaints? Okay. So we're starting off with a almost empty directory. This war file, I'm not a big Java person, but I think it's just like a jar, but it's called a war. You can download this from Gerrit's website. Whatever the version is, 2.8.1 was what was current when I downloaded this, but there's probably a 2.9 or something by now. I don't know. So go to the website, download the war file, put it in some directory. What you're going to want to do to run it is something like this. And this is all in the instructions that are in the slides, so don't worry about memorizing this. So all this is saying is run Java against that war file, send the command init into the main function, -d dot tells it put everything, install everything in the current directory. So I'm about to fill this directory up with all sorts of stuff. Okay, it's going to ask me some questions. Where do I want the Git repositories? The Git directory is fine. There are a number of options for databases, and I think you can actually extend this, but H2 is some kind of embedded simple database. That's the default option, so we'll stick with that for now. What I'm going to do a bit differently for here is the authentication method. I'm just going to use this development become any account, because that's the easiest thing to do by far. I don't have to set up LDAP or anything. So development become any account. And this is what I suggest you do too as well. If you want to do experimentation and to set this up for your group, just use this, because then there's no need to touch any other systems or do any sort of other configuration. It just means that anybody can become anybody in the system. So hopefully you trust your coworkers enough to do that. I'm not going to worry about SMTP, although Gerrit, I'll warn you, can send a lot of emails. If configured in certain ways, you can get emails about any time anybody looks at your stuff, makes a review, etc. And some people find this annoying. So you may at some point find yourself learning how to turn down the email volume from 11 to 5. But I'm not doing any sort of configuration for that. Run as me, use that Java, copy Gerrit. There's an SSH daemon, of course. Just wanted to listen on 29418. No, I don't want to download anything. I don't know. I'm going to ask it to listen on localhost, because for some reason star doesn't always work. Port 8081, that's fine. No. Okay. It's going to think for a few minutes, and now I've installed Gerrit. That's it. So don't be afraid to try this at home. This is really super easy. You can see what it's given us here is a couple of, most of this you don't ever have to worry about. The Git directory here is going to contain a bunch of just Git repositories, vanilla, normal Git repositories. So if you ever need to kind of go behind the scenes and see what's going on, that's where they're all going to live. The other directory of any sort of import is the bin directory, because that's where Gerrit.sh or Gerrit.bat, whatever, depending on your platform, is going to live. So if we look in Git, we'll see that there's one already made for us. This is basically an administrative repository you should never have to worry about. If I look in bin, I see Gerrit.sh. So we're going to run that. Tell it to start, and it thinks for a few minutes, sets up some databases, does Java stuff. I don't know why it takes so long. But in a few seconds, it will tell us it did not like that at all, and I don't know why. Good Lord. Okay, let's see. This is demo effect. This has literally never happened. Okay, I see what's going on. I already had a running Gerrit. Okay. Let's try that again. And it should be just about good. Now, great. So it's telling me everything is working just fine. Let's go over and see if that's the case. Localhost 8081. Great. So there's a Gerrit. Well, let's actually start from the top. So this is what Gerrit's going to look like the first time you try to log into it. So the first thing you want to do is create a new user. And that's easy enough to do because we can become anybody we want at any time. My preferred email address is a@60north.com. And I'll be called 60north. Save those changes. And then I grab a username, select username. And one thing you need to do for almost all of your users, because you're going to want to use SSH, that's by far the easiest way to do the Git traffic. So I'm not going to go into the details of how to get your SSH key, but hopefully you know some sense of how to do that. But I just do a cat /SSH pub -pp copy. So that's just copying my public key. You just paste your public key, which is going to be in a file called id_rsa.pub or something like that. You just paste it in there and done. Okay, so we've created a new user. The next thing we want to do is create a project. The only project we have right now is that all projects repository, which we don't actually get to see. So if we go to the project list here, I see that there's none. So let's go ahead. Oh, actually, we do see it. Okay, very cool. We're going to create a new one, and we're going to clone from some existing repository I've got in a second. So the project is called Roid Rage, and this is an asteroids clone in Pygame. Okay, cool. So let's go ahead and save those changes. Yeah. So if you look at a project page in Gerrit, you'll see a whole bunch of largely uninteresting stuff here that you probably don't need to worry about until you become more sophisticated and have larger interrelationships between projects. The one thing that is really important is the URL that you're supposed to clone from, the full command to clone from. So I generally use the SSH because that's the easiest to set up and sort of maintain over time, although your tastes may vary. So all I need to do now to get this project is copy that command, go back to my shell, paste it in there, and it didn't like that because of known host. And this is just I can't see my cursor for some reason. Okay, so I just have to remove that line. You'll never have to do that. This happens because I'm running more than one Gerrit server and it messes up SSH a little bit. So fix my known hosts, clone again, yes, okay. So now, if I look, I see this Roid Rage directory, and that is the repository that I just cloned from Gerrit. So what I have now, just to kind of let the dust settle a bit, I've created a Gerrit repository, or a Git repository managed by Gerrit. And then I've cloned that. And of course, that is completely empty. We have no code in it. The only thing I've got there is a .git directory. And in fact, if I try to do a git log, it complains there are actually no revisions whatsoever in this code, which is fine. That's exactly what we expect. What I'm going to do now is clone from some existing project that I've got on my hard drive somewhere. And this is what you can do if you're trying it out with your project team. If you have an existing Git repository with all your stuff in it, you can just clone from that and work against Gerrit for a while to test this out. So all you really need to do is pull from, so this is a directory of my existing Git repository that has the Roid Rage project in it. I'm going to pull from the master branch of the originating repository to the master branch of this repository. It's going to tell me it's done, and there we see, indeed, I have a whole bunch of code. And we can try it out just to prove a point. I picked something that was kind of fun because we can actually see a video game. Okay, great. So this guy's going to shoot asteroids all day long. That's his job. So the code works. We have a working project now. Another breakpoint. the place we're at now is I've created the Git repository in Gerrit. I've cloned it to my developer machine. I've cloned another project in to my developer repository, and I need to get that up into Gerrit. So what I want to do now, go away. So I want to push to origin, which in this case, of course, is the Gerrit server. And again, if you're not up to speed on Git and I'm talking past you right now, just let me know, and we can maybe clear the air a little bit. But I'm going to push origin. I'm going to push my head ref to refs heads master. Now, just a note on this. Sorry, that's mistyped just a touch. That is hard to read. Okay. We talked earlier about the refs for your reviews, and it was refs for branch name. Heads here is going to completely bypass the review part of Gerrit. This is basically saying, take what I have in my local repository, push it directly into the head of the master branch in Git. So this is a way, if you want to get things into Gerrit and bypass the review process, because I don't want to review all this code, I already trust it, you use refs heads master. I probably should have documented that in the slides somewhere, but this is something you generally only have to do, once per project kind of stuff. So that's done, and in fact, if I now leave the word reg directory, destroy it, and then reclone from Gerrit, I'll see that all that code is there. So we're at a point now where I'm actually hosting the project up in Gerrit, and this is kind of the steady state. This is where you generally be. So what do we want to do next? Let's go and see. There's nothing we need to do here. We've created a user. We've created a project. At this point, I have no outgoing reviews, meaning that I haven't submitted anything for review. I've got no incoming reviews, so nobody's asked me to review anything, and I have no recently closed reviews. This is typically where developers will come, like at the beginning of the day, to kind of see where things are, and throughout the day they'll check this to see the status of things. What we want to do now is actually create a change. So make a very simple change. That should be readable. All we're going to do is use a different rendering function for the roids. So I'll disable that guy. I'll enable that guy. Go back to this. So now I've got, if I do a git status, I can see I've modified roid.py. So I've made a little bitty change. Roids are now circles, which is actually the change I made is instead of rendering rocks, it just renders circles. It's a very boring change. Now, this is going to fail. Well, no, sorry, it's going to fail when I try to push it. So git push origin. Actually, let me clear that. And refs for master. Now here we see the first magic ref we use. Now I'm saying, take what's at the head of my development branch on my local machine, push it up for review on the master branch in Gerrit. So this is referencing one of those magic refs. This is going to fail. So what is it failing because of? It's telling me that I don't have a change ID. Just believe me, that's what it's telling you. It says, one suggestion is that I just paste this. It generates a change ID and says, you could use this if you want. You need to put this in your git commit message for what I just tried to push. Alternatively, you can install a hook. It gives you a command to run that will install a hook. Well, we're going to do that because that's extremely convenient to have in place. You have a commit hook in your developer branch, in your developer repository that adds a change ID for every new review, every new commit you make. So let's go ahead and copy this. This is really hard to read, isn't it? Okay, copy, Control B. It's going to run that. I'm going to amend my commit, and what it's going to do is post-commit, it's going to insert a change ID. So let's just do that amend. Now if I do a git log, I can see that there's my commit message, and there's the change ID. So some big UID, it just generates that for you. So now I should be ready to push. So let's try that again. Great, it liked that. So let's go see what that looks like in the Gerrit interface. So now I've got an outgoing review, and my commit message is there, so I can pretty easily see what I've tried to do. At this point, as a developer, I think I misspoke that, you will typically move on to something else. You've taken the change, and you've pushed it into Gerrit, and you've asked other people to look at it. You may assign some reviewers to it, but you're ready to move on to fix the next defect or create the new great feature, whatever. So what you want to do now is go back to your local developer machine and basically abandon the change you just made locally, because you're waiting for it to go through the review process. You want to get back onto the head of the accepted development branch that has merged in all of the good commits so far. So let's do that. Let's move our developer on. That's a hard word to say. So typically what I would do to do that is fetch, just to get things from the origin, and then check out origin master. So now it's telling me a bunch of good stuff you don't need to worry about, but basically I've abandoned that change that I just made. It's up in Gerrit, but I've abandoned it locally. I'm working now on a clean head, clean development head. So I can start working on whatever I want. So let's now kind of switch hats. Let's go back to Gerrit and pretend that we're the reviewer. So I'm coming in with somebody else, another developer, somebody else on the team who's been asked to do a review. I come in, I'm not going to create a new user for this. We're going to do it all under the same user, but I would see this same review under incoming reviews. Click on it to see what's going on. I can kind of see some information about what happened, when it happened, branches, all that kind of stuff. Typically, you use blow right by, all that kind of stuff. You want to come down here to the patch sets. We only have one patch set. Remember, that represents a single diff, a single commit, basically, associated with this review. So I might look at the commit message to get a sense of what I'm about to look at. And then I want to come down here and look at all the files that have been affected. In this case, it's one single file, very small. Click on that, and I can see the diff. And scroll over a little bit here. But it's a very simple diff. The details are sort of irrelevant. At this point, I can scroll through all the different files that have maybe involved in the patch set and kind of see what's going on and start to make comments. In this case, I'm going to make a simple comment and say, please use more descriptive names for these rendering functions. Great, because they don't really tell you what they do. So this one renders rocks, this one renders circles, who knows that? So I've made my comment, I don't like it. I don't like the commit, I don't want it merged into the head, so I come here to review, and I say, do not submit. I don't like this one bit, publish those comments. And you'll see here now that the reviewer has caused a big red X to appear when you review it. So you, the developer, now have to deal with that. So remember, from the developer's point of view now, he's moved on. He's working on something else. He's fixing some other defect. And he gets an email that says, by the way, your review has been rejected. What do you want to do about it? So he comes back here. He, she, sorry, I shouldn't be saying he all the time. Come here. What he wants to do, the developer wants to get back to the point where their original patch set is in the Gerrit DAG, the Gerrit trees. It is a graph. Gerrit gives you a way to do that, a very easy way. It gives you a URL. This URL, you get a URL for each patch set. It's actually a full command that lets you copy and paste that into your local repository and it gets you back into your original state. So let's do that. We'll copy that, paste it in there. What I've done is updated my local repository to look at the original patch set that I made. What I want to do is make a change that addresses the comments that were made, and I want to then amend the original commit. So let's do that. Emacs will see that I have done the right thing.
But at this point, if you already made a change of this file, then what will happen?
Right, okay, this is a good point. If I've got other work going on, right, I can choose to ignore the review for a while. I can finish up whatever I'm doing and push it in for review. I can use git stash if I want to just kind of tuck it away. I can commit a draft. I can create a branch. That's another thing you could do. Is there's multiple ways to address that, and really is up to you to decide what the best thing to do is. But yes, you want to avoid merging in local changes with patch sets. So we'll call this render image. Sorry, I know everybody loves watching people type. We'll call this render circle, and we'll call this render rock. I'm sorry. Oh, you're right. I added an extra R there. Good call. Okay. So well, we can do some local testing. We'll just verify that our change is doing what we expect it to do. If I can get it up on the screen, it's very confusing. Yes. Okay. So it's drawing circles now for the asteroids, and this guy, he's still a good shot. It's mesmerizing to watch this guy. And this makes me know that if we ever get in a fight with the robots, we're dead because he's really good. Okay, enough of that. So, back to my shell. I've made a change. You can see that I've made some kind of change to Roy.py. I want to git commit -a just means add all changes, all unstaged changes. Amend. And this is the amend I was talking about before. This is going to basically modify the previous commit with my new changes. Keep the same change ID. That's really key. You want to keep the change ID when you do this kind of stuff because that's the index, again, that's the primary key that Gerrit uses to know what review things are associated with. So git commit amend. I don't need to change anything. Now if I look at my git log, I see I still just have that single commit. Sorry, let me. Oh, we went too far there. Refs for master. And great, that worked. Now if I go, as the developer, or anybody actually, I go to look at this change again, I look and see there's a second patch set. Great, this is what I wanted. And we can look at the second patch set. This is a bit instructive. If I go to the top here, I can see, I can look at the difference between the original code and the second patch set. I can look at the difference between the first patch set and the second patch set. That's often very instructive. Or any combination therein. So imagine I'm the reviewer right now. I've come back, I see that there's a second patch set. I've got an email because Gerrit sends out 1,000 emails. I look at it and I say, well, okay, yeah, you've made the change. Everything looks good. I'll maybe even check it out and run it to see if I like it. And ultimately, I come down here and I review again. And I say, +2, looks good to me, approved, publish those comments. And now I get a green check mark. At this point, the developer's done, the reviewer's done. The only thing that needs to be done now is to merge this change into the head. You may have a specific merge manager, somebody with the privileges to do that. You may be on a team where everybody can do it, and so anybody's allowed to submit. Once you get the green check mark, you come down here to submit patch set, whatever, and you submit it. And now it's in. So at this point, we've made the change. You've seen the entire iteration process. You've seen how it all works. This is 95% of working with Gerrit. This is, you've just seen all of it. So I'm not going to belabor that anymore. Again, what I want to get across is this is really simple. This is low energy, easy stuff to do. If you are interested at all in trying out Gerrit, don't let fear of technical stuff stop you. It's super, super simple. And the notes that I've got in the slides just show you how to do it all. So before we move on, I'm going to shut down the Gerrit server, and we'll move back to the slides.
So this will do.
I'm sorry?
After the code review, once the code review is approved, is there an option where you can automatically check in? It's approved, so instead of doing another manual step, is there an option where you can automatically merge it?
I don't know, to be honest. You mean, can you set up a policy so that if you ever reach a point where you have a bunch of green check marks, that it can, probably so. I've never tried to do that. We've always had at least one person who was generally one person who was responsible every half hour or so to just go see if there's anything to be done, or even twice a day. Because honestly, by the time you get to the point where everything is reviewed, nobody cares anymore. It's all done. It's all in the system. It's in the grinder. It's awaiting merge up to the top. I bet you could though. I mean, there's plenty of ways to automate stuff in Gerrit, so you could probably do it. So let's get back down to my slides. Go back up here and find the slides. Boy, howdy. Okay. There we go. So that's the end of that demo. Any questions?
Yeah, so if you had two reviews set up on working on the same bit of code, and one gets accepted, or all the reviews get accepted, and there's then a merge conflict. I can see how, when you first submit to
Right.
master, that's fine. It looks like, I guess, it's not really an interactive process at that point, is it?
It can happen that when you push that submit button, it says, I'm sorry, there's a merge conflict and it has to be manually resolved. You just get a little window that tells you that. At which point you need to basically rebase that change on top of the head. And there's actually a button to do that for you. There's a button that exists at all times to say rebase on top of, at the head of the branch. So you can do that anytime you want. It simply introduces another patch set in the review, so it's all part of the same process. But that's a good question. And it happens actually all the time, so I should have actually had a bit in there. But you manage it just like you would manage any other merge you get, which is very convenient. Okay, so we looked at the key concepts for, running out of time, key concepts for Gerrit. And like I mentioned, that's the complex part of what I was going to talk about today. Gerrit is by far the more novel, interesting bit of this whole exchange. Jenkins is much simpler because, by and large, developers never really interact with it except to see that it's told them that they've done something wrong. They don't have to configure it, they don't have to submit things to it, et cetera, et cetera. A few key concepts. Jenkins is a web server. This is how you primarily interact with Jenkins. It puts up a nice web page that looks a lot prettier than the Gerrit one. I think there's a much bigger Jenkins user base in the world. Don't worry about what's all there, but primarily Jenkins, you interact with it through the web server. Probably the most central thing, the most central concept in Jenkins is this notion of a job. And a job is just a description of a bunch of tasks to run when a certain event is received, or when the user pushes the button, or when a certain set of conditions are achieved. You can, as I said, trigger jobs manually. They all have a button that says run now, or you can have them hooked up to events of different sorts. In our case, these events are events coming out of Gerrit saying a new patch set has been created. Examples of what jobs can do are build projects, run tests, generate installations, push the code out into your working servers if you're doing web stuff, do whatever, run performance tests. That's something that I've had to do. Jobs can do all sorts of stuff in terms of interacting with the operating system. They can execute shell scripts, run arbitrary processes, do anything. And there's some more details that we'll get to in a second, but jobs really are the core of what Jenkins does, that it manages jobs. Part and parcel of jobs are execution nodes. So you set up some number of execution nodes to actually run the jobs. I mean, in the case, I've got Jenkins running on this machine, and it just uses this guy as a node. I think you can use up to 2 cores. It's very fancy. But you can have nodes that run on developer machines. You can have them running in the cloud on Heroku or Azure or whatever. All they have to do is run this Jenkins slave service that kind of interacts with the Jenkins server. The selection of nodes, so when a job is executed, it has to figure out which node to run on. You can configure things so that all jobs can run on all nodes, and that's fine if that works for you. More often, you will do things like you can specify tags on a node. I can go to a machine and say, this is a Windows machine, 64-bit, something, something, something. And then in the job logic, you can say, only run on systems that have this combination of tags, or have this tag and not this tag. This is basically this matching logic that's based on tags. You can even get more complicated and use these tags in your job scripts themselves. These all become available through environment variables by and large. But the basic concept is very simple. A bunch of machines that are able to do the work that Jenkins needs done. The Jenkins machine can be one of those. Just as a side note, I mean, if you want to set this up kind of ad hoc in your development group, we had a long-running system where developers, this is a C++ system, huge, lots of code, and very resource intensive. So if developers are doing builds on their machines, they needed all their machine time. They were also running Jenkins build slaves, and we just had those slaves run at some super low priority. And by and large, that worked just fine. Nobody was complaining that they didn't have enough processor power or that they were being swamped. So you can run these slaves on your developer machines. You don't have to go to your manager and ask for a build farm or something like that, or money to buy Azure nodes. So nodes, very important in Jenkins. The sort of third leg on the Jenkins stool is plugins. A great deal of functionality is provided to Jenkins through plugins. There's a small core set of functionality that's built into it, basically job management stuff. Everything else comes in through plugins. And you can get plugins for interacting with source control systems, for different user authentication methods, if you're concerned about that kind of stuff, parsing output, et cetera, et cetera. There's all sorts of different plugins that do all sorts of stuff. We'll look at a few of those later. The real takeaway from this slide is if you're trying to make Jenkins do something and you feel like you're having to do effort, put forth actual effort to make it work, go look at the list of existing plugins and see if any do the work for you, because chances are you're not the first person to try to use Maven from Jenkins. I mean, it's not likely. So somebody's figured that out for you. And actually, Jenkins, the server, the HTTP server that's running when you start up Jenkins has a list of all the available plugins. And so it's really easy and convenient to find them and install them, and everything just kind of works. So let's do a quick tour of Jenkins. Just like I said, I have one running here, and so this is this guy over here. This tour is going to be far less intense than the Gerrit one, because I'm just going to show you kind of what it looks like. This is the main page when you ping Gerrit. You'll see all the configured jobs here and some little like QD indicator of their status. This is saying that, yeah, its last build was fine, but it had a lot of failures right before that. So you can get a quick overview. You know, if you're a manager, you want to come here and see, you know, what shape stuff is in, how crappy your developers are. Over here, build executor status. These are the nodes. This is an indicator of what nodes are available, which ones have gone down, which ones are doing something. So if I had a build going on, it would actually tell me that it was doing something here, and I would see builds waiting to be done. So you can actually end up with a big queue if you're not careful. By and large, this is the page that developers will come to. If they've gotten a ping that, for instance, they submitted something that failed, they might need to come and look at a particular job and find the red build that failed. And then almost all they ever need to do is come and look at the console output, and that tells them, you know, what failed. In this case, the unit tests failed. So very simple. If you're the one running the server, you're going to come here and you're going to spend a lot of time under managing Jenkins. Ignore this warning for now. It just means that my standard Gerrit server is not running. Most things are very self-explanatory. If you come in and say you spend a lot of time to configure your system, if you want to know how to do anything, you wait for Gerrit Jenkins to respond. Most things are very easy to understand, and if you ever get lost and need to know, you can click on these question marks. It's very, very well documented. There's a really good user community out there as well. Stack Overflow has all sorts of answers about Jenkins and Gerrit for that matter. So again, I'm not going to go into a lot of these details. Just kind of, that's the high-level map: nodes, jobs, configuration. Adding new jobs is really straightforward. Adding people is generally very straightforward as well. Everything else, not really worth worrying about. Okay, I did mention plugins, so if you ever want to find out which plugins are available, this is the list, and it's pretty extensive. So, like I said, if you feel like you're missing some functionality, come here and scan this, and Control S and find, Control F, sorry, it's not Emacs. Right, so that is the 5-cent tour of Jenkins. Why does it do this? Right, let's try that again. Boy, Mac. I apologize. Good Lord. Okay, I think I know what's going on here, sorry. This is the first time I've done this demo stuff, so I clearly don't know how to run two monitors at once. There we go. Okay, that was the tour of Jenkins. Finally, the grand finale, so to speak, in terms of functionality, is how do you make these two talk together? It's not going to surprise you too much to know that the answer is a plugin, a Jenkins plugin. So there is this thing called the Gerrit trigger plugin, and all its whole job is to be configured to listen to a Gerrit server. Gerrit servers can spin out little events, and when it sees the right events, trigger a job. So go into your list of plugins, find this, install it, and the rest of this is just a nice screen cap. Setting it up is actually a little bit fiddly, and I want to go over some of the details and actually show you the configuration in some amount of detail, just so you, hopefully it'll stick in your brain enough that when you try to do this on your own, you'll remember. All the instructions for doing this are on the web. There's great resources for that if you ever get stuck. One really key thing is this thing called the Gerrit ref spec. That's an environment variable that's set by the Gerrit trigger plugin when it's instructing Jenkins to run a job. And what it is the ref, basically the branch to grab from Gerrit to build. So if you're running a build based on Gerrit, this is going to need to be set. The reason I tell you that's normally automatically set. Something happens in Gerrit, event gets to Jenkins, that gets set, everything gets built, nobody has to worry about it. If you ever want to run a Gerrit-based job manually, though, you need to ensure that this is set, and there's a way to do that we'll look at in a bit. It's really easy, but it's also something that's easy to forget, and when you don't do it, you kind of scratch your head for about 10 minutes trying to figure out what you forgot to do. So Gerrit ref spec, burn that into your brain. So linking them is actually very straightforward. So let's drop out at my own risk once again to look at the configuration of a Gerrit job. So this is a Gerrit-based job that, okay. Most of this is very self-explanatory, the description, the name of the project, etc. Here's Gerrit ref spec showing its ugly head for the first time in real life. If I want to be able to run this job, here's build with parameters. This is basically explicit build. No triggers actually occurred from Gerrit, but I want to run it anyways, basically to test the plumbing, or just for the fun of it. When this runs, it has to know to set the Gerrit ref spec. And so if I tell it the Gerrit ref spec needs to be set, then it will ask me to set it for it. Don't get too confused. It all makes actually perfect sense when you're doing this in real life. Let's go back to this. A few more things you're going to have to set. You're going to have to set up. Ignore the red again. I just haven't started the Gerrit server. You're going to tell this that you're dealing with a Git repository. Jenkins knows how to work with Git repositories in general, and since Gerrit is just a Git repository, this is no problem. So I've told it this is where it needs to get things from. This is the Git repository to work with. I tell it I want it to work with only the master branches. Again, there are these question marks. If you ever get confused as to what these things mean, click the question marks. These will save your butt every time. But you need to tell it the Git server to use. You need to tell it which branches you're concerned about building against, which things you're ever going to be pulling from. And you want to tell it how to know what to build. Strategy for choosing what to build. When you install the Gerrit trigger, installs the Gerrit trigger option into this drop-down list, so make sure that's selected. Build triggers are a Gerrit event. It's a bit strange that you need to specify this twice, but you do. So you need to click that up here as the strategy, and you need to tell it the build triggers are a Gerrit event. You're able to select the correct Gerrit server to use. You can actually configure multiple Gerrit servers inside a single Jenkins instance. So if you have, for some reason, extremely complex build infrastructure, you may have to do that. Tell it to trigger on patch set created or whatever events you care about. Patch set created is the most typical one because that just means that some developers pushed a new patch set into a review. And generally you want your build system, your test and build system to run over every one of those because that's the feedback that developers are looking for. Oh, that's right, I have to click that. And there's some logic here that I cannot scroll to for some reason. For selecting, I apologize, I'm not sure why it's not showing this entire box, but basically you have to tell it which branches to clone that you're interested in working with and, which repositories and which branches you're interested in building. All this makes much more sense when you're doing it because you'll have the whole infrastructure in your brain. I'm just trying to give you a high-level sense of how this all is put together. And the rest of this is Python stuff you don't have to worry about. So that is the 5-cent tour of how to set up a Gerrit Jenkins link so they talk to one another. The only thing to really remember to take away from that is there's the Gerrit trigger plugin you have to install and the Gerrit ref spec you have to set if you ever want to manually run a build. I was going to actually show you the full cycle of making commit to Gerrit and having that go through the Jenkins cycle, but it actually is not that instructive, so I'm going to skip that and just go back to the slides. Right, good, I did it right that time. Because that leaves us time to look at some of the actually more interesting stuff. So this is the next to last section and the only last section that I wanted to get to. I've touched on this a fair amount already, but one of the keys to really working effectively and getting the most out of the Gerrit Jenkins build system is knowing how to do fast branch switching. And this actually came up earlier in a question, what do I do if I'm doing some work on my local machine and somebody comes with an urgent review? How do I deal with that? Well, you deal with it like you would do with any Git project. You stash things, you create a branch, you move on to something else. All those tools are available to you. So if you've ever found yourself working with Perforce, which I have significant experience with, it's really hard in Perforce to stop what you're doing and move on to something else with any flexibility. It can be done, but it just feels hard. With Git, it's like that. It becomes second nature, and it becomes really easy to do these kind of bounces back and forth. You have to do a critical fix of some sort. You can just immediately drop what you're doing, have it saved, make that change, push it into Gerrit, get it all tested and be done with it and go back to your work. So there's never any downtime. There's not a whole lot of time spent in switching contexts. You're kind of always moving forward. And so you're really never getting out of the zone, of the, sort of the coding zone. And this is wonderful. It feels great. Your days will fly by. You'll get so much done. The main point, fast branch switching, get good at this. If you're learning Git, pay attention and read what the experts do and learn how to really kind of juggle multiple threads of progress at a time. Yeah, the basic cycle is very simple. You save your current work using whatever technique you want, fetch the new branch, do your work, submit it to Gerrit, and then switch back. Fast branch switching is really key. Yeah, like I said, this is just the Git workflow. This is not unique to Gerrit in any way, shape, or form. This is a lesson that we learned. Is that showing up? Well, this arrow is going all the way into here. A lesson we learned, when you set up a job in Jenkins, you have basically this little text box on the web page where you can enter a bunch of commands that you want it to run. And those can be as complex as you want. All sorts of shell commands and stuff like that. That's great. What we found is a better strategy is actually to make a script, a Python script or a shell script, whatever you want, store that with your source code, revision control that, version control that with your source code, and have the job do one thing and one thing only, call that script. This is great because now what you do, this script is the thing that runs all your unit tests and your acceptance tests and does your build and all that kind of stuff. You can evolve that as time goes on. If you develop new tests, you just build them into this script. The alternative is that if I come up with some new acceptance test, some new fancy thing I want to do, I have to create a new job for that. Basically clone an existing job, add a new line, and have that know which refs to pull from and which not to pull from. You have this crazy relationship between Gerrit and Jenkins. It's much saner, much more scalable, flexible, easy to reason about, easy to maintain if you just have this script to be part of your normal source code. It seems like common sense when you hear it, but because it is common sense, it's sort of like post facto common sense. Hindsight is 20/20, but you almost certainly go down the road initially of entering a bunch of commands into the text box on the web page and storing that with the job, because that seems like the easy and convenient thing to do, but it will bite you in the end. So, word to the wise, do this. Keep it simple, keep it version controlled, have Jenkins do just the minimal call this script. Does that make sense? I feel like I might have left details out, but okay, I'm getting a lot of nodded heads. Get used to creating new jobs. I know I just told you that you want to avoid creating new jobs. Well, you want to avoid creating duplicate jobs. You want to avoid creating branched jobs. But get used to using jobs to do all sorts of stuff. Remember that Jenkins is not just a build system, not just a test automation system. It's a job automation system. It can do anything. So you can have it set up to do standard patch checking, which is like what we've been talking about for most of this presentation. You can have it do this sort of daily heavyweight testing that maybe takes a couple of hours, so you run it at 3 in the morning kind of thing. Generating builds, bisecting defects, which is a pain thing to do, but it's easy to make a machine do it because it's really automatable. All sorts of stuff. Static analysis tools, I'm a big fan of. Building releases, that kind of stuff. Be creative with jobs. Remember that they can do pretty much whatever, and they can be triggered by whatever you want them to be triggered by. So there's no reason to be limited to just things like builds and running tests. A few interesting plugins that are worth keeping in mind. This is used very widely, this notion of matrix jobs. In fact, it may be now is not a plugin. It may be actually integrated into Jenkins. The idea is that you have a job that's sort of a template job. It has a bunch of instructions on what to do, but it has certain holes that you fill in. The classic example is that you want to maybe do a release build and a debug build and a profile build, for example. So you define these things called axes and axis. And you say anywhere you see in the job, you see the word variant, run it once with debug, once with release, once with profile. And so these are probably going to be part of the command to GCC or something like that. So you'll have a single job that you can parameterize as many ways as you want, and it'll end up running 3 times on 3 different build nodes or something like that. The neat thing is you can have multiple axes as well with a single job. So I can have I can have the variant, and I can also have maybe multiple Python versions if that's the kind of project you're running, or different Java versions or something along those lines. So you can have basically this cross product of a whole bunch. You can have 10 different axes if you have enough build nodes to support that in a sane way. So this is a way to define a single job that does a bunch of things that are very similar but a little bit different. So it's a useful tool and save you a lot of repetition. Associated with that in some sense is this notion of job pipelines. This is another plugin that has received a great deal of use. I've only used it in sort of experimental, just to kind of see how it works. But it lets you build what are called pipelines, sort of flows of jobs that can kind of branch and stuff like that. And this is apparently very, very common in people doing web development. They want to be able to quickly make a submit and have it go through the proper channels and get up to being running live on the system. And they can come in here and they can kind of see, oh, this has worked, this is in progress, that worked, those are pending, or maybe things go red when they fail. So this is a way to construct complicated pipelines of the flow of your release cycle. And I think that's typically how it's used. I can't give you a great deal of more insight into exactly what to do with it, except know about it and look at it, because it's very, very, very popular. So I assume that it's very, very, very powerful as well. That is the last slide on the interesting bits. This last section, we have some time to go into stupid review tricks. One of the fun things about Gerrit, one of the interesting bits about Gerrit is it also has a REST API. It's a kind of a crappy REST API, and it's evolving as we speak. But it's there nonetheless, and what it does is give you a programmatic way to look at all the history of everything that's gone on in your reviews. And that's a real treasure trove of data. If you're interested in doing data-driven analysis of your development practices and stuff, this is another entry point into what your developers are doing. How many reviews does it take to get, how many patch sets does it take to get a review through on average? Who knows, but if you have access to all this data, you can start to calculate that, and you can graph that. Yes?
Does it have any dashboard out of the box?
Oh, you mean that shows that kind of information?
Yes, so something already built, or are you supposed to have your dashboard then?
Not that I know of. I don't know of any sort of analytics dashboard. Somebody may have written one that I don't know about. It's entirely possible. The sad fact is that I found out there was a REST API and I decided to try and use it without doing any research. So really, this last bit is just kind of showing the kind of things you can get out of that API. I'm not a scientist. I'm not really. I don't have the patience to do real science. But this is heading in that direction. Maybe somebody out there does have the patience, and they can find there are some interesting patterns that we should see coming out of the data. If you want to know how the REST API works, this is the API. Memorize it. It's in the slides. To work with that REST API, I wrote a little Python library called Yapka, yet another Python Gerrit API. Basically, it is Python. It's using the natural language toolkit, NumPy, and Matplotlib, and it talks to Gerrit and does a bunch of fun stuff. It's pretty extensible, so if you feel like checking it out and adding features to it, I'm all for that kind of stuff. You can get it from GitHub right here. Yapka works in a pretty straightforward way. It can go to a Gerrit server and basically fetch a bunch of data, and then it will cache that all locally. Right now, it's writing to a MongoDB. The reason I do that is because reading all that data is fairly expensive. And a lot of these Gerrit servers that I've been pinging are open source projects, and I don't want to melt down their machines by constantly fetching a bunch of data. Plus, that's very slow. So if you use Yapka, the first thing you do is tell it to fetch a bunch of data and store it in a database. And then all the work that it does afterwards is based on the stuff in that database, which you can update if you want to. Here's an example of the command to fetch from the Android Gerrit installation, which I should point out, I think Gerrit actually came from Android. I think this is something that they maybe copied from Google, this Guido van Rossum's review tool. Anyhow, the fun stuff is you can get graphs like this out of your data. And what this is showing is the revision size versus patch set count. You can all read, so you know that. But what that is, revision size is basically the gross size of the patch, the diff, basically, how many bytes are in the diff. There's a smarter way to measure that probably, which is the size of the compressed diff, but I'm not doing that because I didn't think about it until a few days ago. But basically, revision size on the X, number of patch sets in a review on the Y, and what you kind of expect to see, what I intuitively expected to see, was that as the size of a patch, as the size of the initial diff grows, the number of reviews required to get that through should grow as well. And you kind of see that. You squint, you can sort of see that growing up here. What I didn't expect was this. Was it craters?
Nobody reads that. Nobody reads a million line change.
Well, this is where some insight and some research needs to be done. Why are the million line changes, and why does it take one review to get that through?
Whatever.
Yeah, these are probably huge refactorings, like capitalizing some central class or something like that. But yeah, I didn't intuitively expect to see this rise and then a crash like this. But we see that not only with Android, we see it with AOKP. I don't even know what AOKP is, but they have a public Gerrit server. you see the almost exact same shape. It grows and grows and grows, kind of like you'd expect. You get this fuzzy cloud at the top, and then it craters again. And you see it also with CyanogenMod, which I think is an Android rooting OS or something like that. I don't know exactly what it is. But this is the kind of thing that I think is really interesting. I mean, doing this kind of work with reviews is fairly novel. People do this kind of stuff with revision control systems all the time. They kind of mine them to find data, and I find it kind of entertaining. I called it stupid review tricks because that's really what it is. I don't know what to make of this beyond the fact that we see the same pattern every time. And so if I saw a project that didn't have that pattern, I wonder why doesn't it look like every other project in the world? Or maybe these are 3 outliers that aren't representative. But you can find that kind of stuff out. And if you run one of these internally, you can download Yapka and you can run this every day and graph these. And maybe you'll learn something about the way your development team works. I don't know. There are other things we can see. This is revision count, the revision count histogram. So basically, how many revisions, how many patch sets were there in a review, and just make a histogram out of it. And it's more or less the shape you'd expect. You know, a lot of the lion's share of reviews have a single patch set, and then it drops off pretty aggressively there and just tails out forever and ever. Okay, this is the AOKP project. You see the exact same shape. And there's a bit of a strangeness here in the CyanogenMod graph because they have a bunch of 0 patch set reviews. I don't know what to make of that. I haven't gone back to look through the data yet to see. I'm sure it's fine. I'm sure it's just some systematic thing that they do. But it doesn't show up in any other data sets that I've looked at. So another fun thing, maybe it's instructive, maybe it's not. Maybe if you came across a project that had this kind of shape and then a peak out here, you might wonder, what the hell's going on? Why is there this strange pathology out in this particular project? Maybe it's meaningless. This is really just showing off what you can do with matplotlib more than anything. But this is a heat map of how often reviewers review specific owners, right? So like you can see here, whoever this owner is, he's been reviewed a bunch by that guy. It's probably himself actually, because all of these graphs show this kind of diagonal through the middle. And this diagonal, I've probed it, and it turns out that that's people looking at their own reviews. That's what that diagonal is. But you also see things like these obvious lines, what I call obvious lines. Maybe they're not, maybe that's my brain interpreting what it shouldn't interpret. But this looks like a lot of high activity. This guy's getting a lot of things looked at by these people here. And you might wonder, why is this guy, why is he so interested in his own reviews? And again, you can ask, do we see this pattern over and over? Oops, sorry. And we do. This is the AOKP project. And you see, if you squint, the exact same diagonal here. You also see these strange, strong lines coming through. These guys are really active reviewers, is what that means, I'm almost certain, because they're looking at a lot of stuff, so they show up with these bright, solid lines. You see the exact same thing in CyanogenMod. Very strong diagonal. Very strong lines across. These are the, these are the superstars. And you can start to see this kind of stuff in your own development team. I doubt your development team is this big. This is actually something like the top 10% of reviewers and owners. So I've stripped out literally thousands of reviewers from this, but these are the heavy hitters, the big guys. If I left everybody in, it would be this big sea of blue with a pixel of red in the middle. It'd be impossible to read. That's sort of numerical analysis, and we have just enough time to do maybe the most fun stuff in this entire presentation. NLTK is the natural language toolkit. It's a Python library for doing natural language stuff. This is a very uninteresting graph because this is uninteresting, mark my words, because this is measuring, this is a histogram of word frequency. And what you find out is that, well, you expect things like the word change and commit and which, it, and on to show up a lot, and they do. Okay. What I need is a better filter list, or what they call a stop list, and I haven't developed that yet. So this is not as exciting as maybe it could be. But a really fun thing that NLTK can do is generate text. You give it a big corpus, a big body of text, and you tell it, make something that looks kind of like that. And I did that with the Android project, and you get something that's almost poetic. Patch set 1, I don't matter, I'm not in Google's internal Android source tree. This patch set was cherry-picked to change something, something, something. It actually, you feel bad for this guy. He's not real. I don't matter. But this reads like almost, I mean, we could clean it up a little bit, but it reads pretty well. If you were glancing through it quickly, you'd believe this is probably a real commit. And you can, It's sad. Yeah.
Yeah.
Yeah, bro. I'm so sorry. I don't matter.
I have a team member who puts passive aggressive. Come in and makes one that.
It's changed from Swiss to it shouldn't be.
Yeah, it's just fine. Yeah. So there's, I try to get it.
Complaining about the product team. So
Yeah.
Human,
Oh, okay. Well, if he complains enough, it'll show up in the stats, and you'll get those out of his tool. Here's another one that kind of interesting. Also, this is a real stupid review trick. There's no redeeming value to this other than it makes you chuckle. So this is built into Yapka. So if you want to download Yapka and run it against your Gerrit, please do so. I would love to see somebody else try this out. And if you have ideas on kind of analysis you would like to build into the tool, let me know, or add it yourself. It's very extensible, very easy to use. Right, so then we're right on time. Thank you, and if you have any questions, I'd be happy to take them now. I think we have this room a half hour until the next talk, or grab me or tweet me or whatever. Thanks for your time.